Good day, everyone. My name is Patrick Ryan Estacio, and together with my partner, Rafael Matias, we are ready to explore the physics of our universe by means of conducting an experiment. Now, have you ever wondered why objects are naturally being dragged down towards the center of the Earth? This phenomenon could be explained by the concept of gravity. So, in Sir Isaac Newton's words, he described gravity as a mysterious force at a distance. Or in layman's term, gravity is an attractive force between two objects with mass. On the other hand, Albert Einstein described gravity as the bending of space and time. But that kind of description seems to be way overcomplicated. So let us stick with Sir Isaac Newton's definition first. In line with this concept, me and my groupmate had an argument recently on which object would fall faster to the ground. A fully filled 1.5 liters of water bottle or a pencil eraser. With that, we decided to conduct an experiment wherein we will test 4 different objects with different masses and drop those objects at the same time on a certain height intervals. Afterwards, with the utilization of the slow-mo feature of our cameras, we will observe which object would hit the ground first. My hypothesis is that the heaviest object will fall into the ground first, while Rafael speculates that both objects will hit the ground at the same time. So, let us find out who is correct. To begin with, on this experiment, we will be needing the following materials. Number 1, measuring tape, as we will drop the objects on the height intervals of 90 cm, 110 cm, 130 cm, 150 cm, 170 cm, and 190 cm. Number 2, weighing scale. This is to measure the weight of our objects. Number 3, camera, in order to record our simulation. And number 4, lastly, the objects that will be dropped. The objects that we choose for this experiment are as follows. 1. 1.5 liter bottle of Coca-Cola filled with water, which weighs 1,500 grams. 2. A pencil eraser, which weighs 12 grams. 3. A lotion bottle, which weighs 98 grams. And 4. A Lego block, which weighs 2.5 grams. Now, without further ado, let us proceed to the experiment. Since our objects have already been weighed, the next step is to set up the height intervals of the experiment. In order to do so, we just need to utilize our measuring tape and put markings on a certain wall containing our desired intervals, which will serve as our reference points.
As we proceed in the conclusion part of this experiment, it might appear that in our demonstration, the objects for both students did not land simultaneously at an infinitesimal length. So, there will be some degree of uncertainty in the results. This is where experimental errors are taken into consideration. It could be observed that the personal error is a type of error present in this experiment, and this is due to the fact that their reaction time for both hands in dropping the objects may vary from one another. Moving forward, as seen previously, both the objects from both students hit the ground at the same time. The reason behind this is Newton's second law of motion, which states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the force in the same direction as the net force and inversely proportional to the mass of the object. By manipulation, we can show that the net force is equal to the product of the mass and acceleration, otherwise known as F is equals to ma. Now, this is where our demonstration or experiment relates. But since we are talking about free-falling objects in our experiment, we could replace the variable a to a constant number g, which is equal to 9.81 meters per second squared. This value is also known as acceleration due to gravity. Also, for the four objects utilized in this experiment, we could surmise that the following factors, weight, size, and shape, doesn't really affect the acceleration of the free-falling object. Even though we could manipulate the equation and change the value of our masses, the value of g will still remain the same, thus making the vertical acceleration of each object equal. And from our trials and results, we can conclude that any object, regardless of its mass, will hit the ground at the same time with respect to their initial height when released perpendicularly to the landing surface. This now proves the concept of gravity. Before this video ends, we would like to quote an answer from Sir Isaac Newton when asked how he discovered the law of gravity. He simply answered by saying, "By thinking about it all the time." And from our perspective, students nowadays tend to neglect the constant values existing on the equations that they are solving and are unable to answer them when are asked about it. Patrick and I would like to remind students that knowledge is gained through repeated experiment and observation. Although proven in the past, one must know how it was obtained. And that ends our demonstration video.